Morning, everyone. It's not a full house. I was thinking there's going to be like 400 people, but then I just heard that next door is security and Kubernetes, and then there's IoT, and there's all these other things which are really cool. And then, if you've been doing warehouses for a long time, and you come here and you go, okay, I'm not sure about this. We're already having a hard time with data warehouses. I'm not sure what this guy's going to give me. But really today, what I'm going to do is I'll just introduce myself. We'll go through a few different points. But so what I'll start with is I'm Paul Macy. I'm a solution architect with AWS specialising in big data analytics and insights. And it's my pleasure to talk to you today about modernising your data warehouse with Amazon Redshift and Redshift Spectrum. There's three parts I'd like to cover off today. Firstly, why modernise your data warehouse? The second one is I'd like to give you an overview of Amazon Redshift and Redshift Spectrum. And then finally, if everything goes well, I'm going to try and do a live demo. And as you know, I think when you work with kids or with animals or with demos, it could go anywhere, but I'm really hoping it's going to go well. I never record a demo because I think that if we can't prove that this thing works just off the bat, it's not a cool thing. So I definitely want to be able to do that today for you. So how many people here actually work with data warehouses? I just would like to know so I can see that I'm talking to the particular type of audience. Okay. And how many of you know how much data you've got inside your database in regards to how many years of data? Do you know much about what's in there? You got a good idea? Yeah? Okay. So let's get started. I'm going to come back to that and talk about, the amount of data. Where's my clicker gone here? We're going to talk about the different data sizes and how data's grown over time, and actually look at how we can actually future-proof our data warehouses. So why modernize? Well, I'd like to share with you a story about a person called Chris. Now, Chris, like me, has been doing data for way, way too long. This person has been doing it 20 years and really was involved in one of the first lot of data warehouse build-outs. And so 20 years ago, she was given the task to establish this data warehouse for an organisation, and she went out to the various data providers. People had spreadsheets and text files and some other database systems, and they wanted to bring them all together. So she asked, what size have you got? What types have you got? And so she said, okay, I can see that I've got about a gig of data, because it's 20 years ago. And she goes, you know what, if I'm going to build this, I've got to future-proof it. So I better make sure that it's about 10 gigs in size so that we can really, really go forward the next 4 or 5 years. And so Chris, sure enough, gets this data warehouse rolled out, and as it goes along, 4 or 5 years comes up, and the data warehouse starts to slow down, and users start messaging her going, you know what, this thing is really bad. It's so slow. I'm trying to do a really basic query just so I can do some aggregations, and it's not working. And the data provider's going, well, this is failing. I can't load all the data anymore. And so she goes, okay, well, that's okay. I planned for this. I know that I've got 4 to 5 years to sort of have this ready and to make it working and making it optimal. It's time to refresh. So she sits down and she says, okay, data providers, what's our new data set? What are the new data sets we've got? What are the new sizes? And so sure enough, she looks at their current state and she goes, well, I've got 10 gig. I know that in 5 years, it's probably going to go to about 100 gig. So she does this whole process again and says, well, I'm going to future-proof it. It's definitely got to go another 4 or 5 years. This will be awesome. And so, she's done this now again and rolled it out. And sure enough, that whole process happens again where people start getting frustrated, things get slower, and it becomes challenging for the business to operate. Now, fast forward that 3 or 4 iterations and 20 years later, and I know she's grey-haired now and she's really tired and exhausted because everyone keeps giving her a hard time. But at the end of the day, she's done an awesome job because she's planned out over 20 years how to keep all of this data available to the organisation. So it's fantastic, right? She's got 20 years of all sales transactions, customer data, all the people who don't even work there anymore. All of this is all sitting in this awesome data warehouse that everyone just does select star on and goes, yeah, I just want to know how many orders did we do back in 1994? Okay. A year ago, something really interesting happened. It was time for her to refresh. She sat down and said, wow, you know what? Things have really changed. We need to really look at these data sets again and talk to the data providers. And sure enough, there was a whole heap of new data sets coming in. The thing that happened though was she went and measured it all and said, well, okay, in 5 years' time, I reckon it's going to go to about 10 terabytes. I reckon we're going to go from, we're about 1 terabyte now, we're going to go to 10 terabytes. And so she rolls out this really multi-million-dollar in-memory database, and not going to say brands or companies or anything like that, but effectively that's what happened. And this is a real true story, by the way. She actually went through and they rolled this thing out. And in a year, it was redlining. And she went, but I planned this. I've done this so long in my life. I know the process here. It should just work. It should be future-proof. This is what it's all about. So she went back to the users of the actual data warehouse, and she went to the data providers and said, okay, what's going on? What happened? And the users go, well, we love this thing. It's so fast. It's so powerful. We've got 500 Tableau licenses now. We're pumping away at this thing. We've got now clickstream data coming in. We've got web interaction data, customer interaction data. We've got logging coming in. But it's gone like this. So where we've been going along in a nice linear fashion, the last couple of years it's gone like that. And she just didn't think that that would ever happen in this particular organisation. So she came to us and she goes, okay, what can we do? And I said, well, okay, how are the users using this data? And she goes, well, actually, I don't know. So back she goes and she says to the users, how do you use this data? And she asked them things like, what sort of queries do you do? How deep do you go with your queries? And they came back and said, oh, well, for our business, we generally look at the 1 to 2 year mark because we want to see what our trends are for the current market, and we can say, well, okay, we need to make a new product because we can see that this one's no longer really valid anymore, and we can see this is really the hot data that we've got that we really want to work with. So she goes, you're saying that this 20 odd years of data that's sitting out here you're hardly using, but you're still querying it when you do select alls and counts of and everything else. So you can see what's happening is that people still do the same thing the same way with these awesome tools, because Tableau is awesome, right? You go in there, you drag up all these different pivots and you go, I just want to know the answer to this, and all of a sudden it comes up with 20 years of data. But you look at the performance of this massive system, it's millions of dollars, and you just see the redlining and it's all the workloads freaking out. So she came back and said, okay, this is the story, this is how they use it. And I said, well, I've got an answer for you. What about if you could have your cake and eat it? What about if you could have your 2 years of hot data sitting ready to go, but at any stage you want to go and get your data that's 20 years old, or we can go and get that from somewhere else and you won't even notice the actual getting of that data in regards to the connectivity and bring it up as a table into the data warehouse. And she goes, how the heck does that work? Well, I said, we can offer something that is going to be performant all the time. As you go along, we can add more nodes and we can grow it. And because we can move all of our data over into a storage layer and then bring it up immediately when we need it, we can manage our costs. Like, you can imagine taking all of that data, all of that information that you're hardly using, the historical data, and moving it over to some storage area. You're going to reduce so much money and cost in running the organisation. So with that, I'd like to introduce Redshift. If you've been using Redshift already, you're probably very familiar with what I'm going to talk about now. I'm going to stay reasonably high level because I know it's a 200, but some of the slides here are a little bit deeper, so we'll see how we go. If anyone walks out, I know that I've got to cut it back. So, what is Redshift? Redshift is AWS's data warehouse in the cloud. It can hold petabyte scale data, the amount of data. It's massively parallel, share nothing columnar architecture. Now that's a really big sentence, right? Because you look at it, it's massively parallel, share nothing columnar architecture. But if we look at what it is from the components here, you can see that if I just show you this part here, this circle here, this represents Redshift, and that's our hot data. Down here, we've got a layer that allows us to get to our cold data. So what we have, if we look at Redshift, and I'll come back to these terms in just a moment, is we have Redshift as a data warehouse, Redshift Spectrum as our interface between Redshift and the cold data that you've got sitting in S3. And altogether, this makes up a effectively a transparent ecosystem for you to manage data at different speeds. So coming back to massively parallel, what that means is that we're able to have inside this Redshift environment a single controller, this leader node that really is what you connect your SQL developer tools with. So if you're using SQL Workbench or you're connecting through with Tableau or anything like that, the leader node says, hey, look, you can come in here like a normal connection. You don't have to be using SQL Server or Oracle or MySQL or Aurora or anything like that. You can actually point to Redshift with a lot of the common tools. So that's cool, right? You just go and say, well, okay, I'm not going to use this particular service anymore. I'm going to migrate across to Redshift for my hot data. I'm not saying you still don't keep production going, that's fine. But if you want to let the business do its BI and do everything really quickly, you can do that with a connection to Redshift. So you can get that data that's got the aggregations of your business transactions or your customer interactions, bring that all into an area which is super fast. But in the lower section, in the compute node, what actually that is where we can actually scale, where we can say, well, okay, as we go along as an organization, the leader node will just sit there doing what it's got to do, but below, we can keep on adding compute nodes as your data grows. So if you've got this 1 or 2 years of data and you're starting to find you're getting still more exponential data coming in that needs to remain hot, add another node. And then you're able to scale without affecting the business. You don't have to really future-proof anymore because this thing, you can take a snapshot, add another node, start up again, choose another size or size of compute so it's more powerful, has more CPUs. Over a weekend, you take a snapshot of the environment, start it up with more compute. It's very, very flexible. There's not too much planning because it works with the business. So back to this columnar architecture. Columnar architecture is really common now in the in-memory database world in regards to how we store data with big data now. And it's a bit like how a JPEG and a bitmap work. If you think of a bitmap, every single color and every single position in that file has to be recorded. So that's a lot of information. Whereas a JPEG, what you're able to do is take the data in the case of the JPEG, you're able to look at all of the colors. It collects all of those colors as an index and says, well, okay, now that I've got a list of all of those values, I'm just going to remember where all the positions are. So if you can do something like, I want to index all of my customer IDs, I want to index all of my dates, I'm able to really quickly dive down to that particular section and say, hey, Redshift, go and get me all of the stuff on that date. It doesn't have to go through like an old database and read row by row and then try and sort it and try and bring it all together. It actually has you can create multiple indexes and actually quickly bring together the data from this array. So that's the ecosystem. At the same time, we're always going back to our single endpoint where we can go and use our normal tools today. Where are we going? So combining Redshift and Redshift Spectrum, you're going to be able to do really fast queries, both from Redshift side, but also from the S3 side, where we use Redshift Spectrum to connect to Amazon S3 and bring the data up as you need it. So you can keep effectively infinite amounts of data in S3 and just bring that up as you need it if you need to do some historical analysis, which you know you don't have to do every day. It's elastic because, as I said, you can put these you can add more nodes. In regards to the Spectrum layer, that's actually transparent to you. That automatically scales with multiple nodes to go and do all of the querying on S3. And obviously, as I've said, it's cost effective because we're only going down to S3 when we need to. We don't have to store it up inside this data warehouse anymore, clogging it all up with data that we don't always query. I love this. High concurrency. By having all of this data sitting down in S3, you're able to allow the rest of the AWS ecosystem to connect to the data concurrently, even other Redshift nodes, all at once without a performance hit. Because we've got Spectrum down the bottom and this connectivity, there's no ETL. It just brings up the data. And you're going to see in a little bit, this isn't a database. These are raw files. These are files that are like CSVs or tab delimited, or they're awk or Parquet or Avro. It just transparently brings it up. But this, for me, coming from a world of doing SQL and coding for so long, I can just lift and shift the skills that my team and I have straight across to an environment that I'm really going to be familiar with. I can use the same kind of tools and the same kind of query language to get the result. All right. So, life of a query. I'm just going to go through this really quickly because I want to show you the demo. I don't want you to miss out on that. So here we go. Life of a query. As you know, we have to select something. When it comes to Redshift, what it does, it says, well, okay, I can do a normal SQL query. The leader node, that top entry point says, okay, what's local and what's external? What do I have to do here? And it splits it up. And once it's worked out what to do, it sends it off to the compute nodes and says, hey guys, you've got to do some work here. And this is how you've got to do it. Some of it's going to be up here, some of it's going to be down there. The compute nodes then come down to a data catalog. Now, this is something I haven't spoken about, but I use Glue for everything these days. If you combine S3 with Glue, it is the ecosystem of AWS. It connects to AI and ML. It allows you to go and connect to other databases, to big data. You can go to QuickSight. Everything just connects. It's just incredible. I didn't realize how awesome it was until you start building out stuff with customers and seeing how in a week you've built a solution that would have taken months before. So the compute nodes actually go then and say, well, okay, Spectrum, I need you to scale out, and you can do thousands of, this all happens behind the scene. You don't have to worry about it. It will go through and scale out all of these nodes to meet your query requirement. And you're not paying for that. The only thing you're paying for is the amount of data that you query back from S3. You don't pay for the nodes, and you don't pay any of that. That's all part of the deal. Let's keep going. We've got the Redshift, the Redshift Spectrum nodes will then scan the data, and it goes, okay, where is everything? It then goes and does all of the work down below here, and it doesn't bring it up until it's brought out the subset of information. So you're not bringing back stuff you don't need. It only goes and gets the components that will actually answer that question that you've asked. And then finally, all of that gets joined back up to the local query up with Redshift, and then voila, your business insight, customer journey, awesome experience, that kind of thing, right? With Tableau or Click or QuickSight or Power BI. It doesn't matter. They all connect. So yeah, so it's super fast. With Spectrum, with these multiple parallel operations, with the ability to go down and do the queries right at S3 and bring back only the bits you need, it's super fast. It's cost effective. Look at that. It's $5 per terabyte scanned. Now that's if you're doing, think of a CSV. You might have all these CSVs that you've extracted out from your data warehouse in the past, and you're going, man, this is going to be expensive. But if you convert that to Awk or Parquet, you can actually shrink the size of the file between 5 to 10 times. And when you're only querying a subset, it's super, super, super powerful. Okay, I'm just going to keep moving because I've covered that. Okay. And again, back to this is the heavy hitter, I reckon, for me, is that we can still use the same language, the same approaches to querying data that we do today, so your teams don't have to feel like there's some kind of like new world, oh my God, we're going up into the cloud, I don't know about all this, it's going to be all different, we're going to use different tools. Everyone can just chill. It actually just works. You can get your SQL Workbench, connect to it. I use Agility Workbench because it's actually dedicated for Redshift, and that's even free. I mean, geez, sometimes you wonder how it all works, but it is what it is. Okay, I've got to do this demo. I need you to see this because I've obviously prepared it like a cake, you know, like MasterChef, and they only pick the best ones, but I've done something similar, but actually nothing's connected. So the journey that I've got to take you on here is that when we work with this data, we're going to have data in S3. We're going to use Glue to go and find out what's inside S3. Glue is then going to expose what's in S3 across to Redshift Spectrum, and then Redshift Spectrum transparently says, hey, Redshift, this is what I can do back over here. And all of this can be done almost like a wizard. And it really is. You just step through and you run a Glue job, and you'll see that later this afternoon. If you go to a couple of other sessions, there's a Glue session talking about how to actually do the transformations. And there's another session where they actually go from taking data from S3. Imagine what I'm going to show you now, because I want to show you the data in S3. And then I want to take you through and see that, but then you'll be able to go to this other session and go, well, okay, Paul told me this morning about S3, and now I want to use not just Redshift initially, I want to use Athena to do some ad hoc querying, but then I want to visualize that with QuickSight. So once you've got this ecosystem, you can go anywhere with AWS. It's super awesome. It's truly amazing. And I've been on your side. I've only been at AWS, 11 months? And I've been where you guys are with data warehouses. I've lived the dream or nightmare of trying to work with crazy amounts of data, and it's been really challenging. So coming here today isn't for me a big sales thing. It's here to just tell you the story of the honest truth. And that story with Chris is totally true with a really big organisation in Australia. So this really does work. Okay, before I show you the code, I'd like to show you the structure inside S3. I'm hoping you've seen S3 before. It's our object store where we can keep all different types of file types. You know, whether it's text, it's audio, it's video, it doesn't matter because it goes into our ML and AI. But what you can see here is I've just got a folder structure it's called Canberra Summit at the top there, and I've just got different folders. Now the folder that I'm going to be using for Redshift is actually this one here, and it's just made up of CSV files because I didn't want to. You know, here you prop up a demo and it goes, oh, it's super awesome, and it's like it's all fake. I tried to do something that was actually like, we're going to use CSV files. They're really dodgy, right? They're slow, and you've got to read it all. But I did it. So we're going to use this folder here, and if I go into this folder, what you're going to see is a whole heap of files, and inside there's all folders, and inside there are all the files. So these could be daily extracts, weekly, monthly, yearly extracts from your data warehouse, and you can see that. Look, they're almost as old as me, but they're old. So we've got S3, we've got glue that joins S3 across to Redshift Spectrum, and the way that works is we actually run a wizard that will effectively do all of the work for you. But in the end, that data from S3 comes across and looks like a table. But it's not, it's still files, it doesn't matter, it's just all magic. And then I've got Redshift running, and it's really this is actually really bad. For some reason, I'm not allowed on my account to spin up a really fast Redshift cluster. I've got to choose a really old one. So it's like smoking, and it's in trouble already. It's like you guys will even have a better one. So, but the journey will be S3, glue presenting S3 as a table to Redshift Spectrum transparently underneath. So how do we do all of this joining when it comes to Redshift? So what I'm going to do is I'm going to flip across to my remote desktop here. Oh, don't need that one. I actually dropped the schema. I actually made sure that before I started, I haven't got anything working. So here we go. This is Agility Workbench, and this is just my SQL journey I'm going to take you through to show you that I can take data from these locations and bring it through to Redshift with data that's local. So inside, just to tell you my Redshift instance here, you can see that over on the left-hand side, you'll see, I should use the laser, shouldn't I? Sorry. Okay, here we go. So over here, this is sitting in a particular, inside the Redshift cluster that I put together. It's only got one node, like one little compute bit. And you can see here we've got event, date, listing, sales. And these are actually just some tables that come from a ticketing system for events like concerts and bands and so on. Now, it's a little bit formulated and everything like that, but it's to show you how it works. All of these tables are actually within Redshift. Okay, so I can query those, but what I've got to do is actually connect to S3 via glue. And the way I do that, how it's going, I was running out of time. Here we go. We've got an external schema called Spectrum, and what that's going to do, it's going to set up a location inside Redshift that says, hey, you know what, whatever I'm about to do next, put everything in there, just create a reference there. Now, this is really important. You'll see it says from the data catalog. Now, this is the name that Glue has like as a default value. It's actually, let me take you back. I'll show you. Then it's legit. If I come back to Glue, it's actually called data catalog. That's the name of the thing. So all I do is I call it, I want to go and connect to this data catalog, this thing that knows about S3 and all of these files. So here we go. So I'm saying to Redshift, I need you to connect to an external location. It's located in Glue. It's going to go into this database called Canberra Summit, which is actually the Redshift database that I've got here. I'm saying to the environment, hey, I need to be able to connect to S3 and I need to be able to connect to Glue. So what I have to do is give it some security. I have to say, hey, you know what, you're allowed to go there, Redshift. You can go and do these things. And then I create it. Now, fingers crossed, because if I press this and it fails, that means the whole show's over. All right, fingers crossed. So now what I'm going to do is I've moved across to my second step, and what I've got here is a single command that says, tell me what I've just connected to Glue, but I've told it nothing. So in theory, I should be able to go here, and down the bottom, we'll see that the tables from Glue that are connected to S3 are now joined. Seriously, one command. It's really like, I'll give you the code. It's like, there's nothing to it. I don't know whether these guys get the pack, but they should. It's really just, there's not much in it. So now that I've done that, I need to be able to prove to you guys that I can do a count on data sitting in the data in that folder, in the S3, and it was 20 odd years of data for these concerts and bands and whatever, so fingers crossed. Now I am on my mobile, through wireless, everywhere, so anything could happen. They said I could use the Wi-Fi here, and I said, nah, it's all right, I'll just deal with Telstra, it should be okay. So it's going through, probably the worst query to do for you guys, I should have done something, pick the first one. So yeah, so there's 1.4 million entries in that S3 structure. So that works, that proves that I can connect to that data. But then I should be able to say, well, okay, for the data that's sitting in sales, which is in Redshift, this lower query, I should be able to join that together with the data that's sitting in S3. I should be able to just do a really quick query and say, get me the top 10 entries of that and just show me that working. So I should be able to join the two together now. So we've got all of these thousands of files, plus the table that's living inside Redshift, and what it should do is join the results together. Okay, so all it's done is saying, yes, I've joined all the data from, I had 2018 inside Redshift, and all the rest of the data sitting inside S3. But you can see through that data there's all sorts of data in there now. It's not sorted or anything, but it works. So, what I'll do now is show you, if we're inside Redshift, and I know this is all SQL, if you haven't done SQL and you just say to the guys, hey, I need you to do this job to produce the output, this is what we do when we're working hard and you just have a coffee while we're doing it. We write this stuff. So here we go. We're going to do select all. We're going to select this, get the sum of the number of tickets sold for a particular event inside Redshift. So just do that first. Jeez, that's fast. I love it when it works. All right. So there you go. So you can see that I've gone into 2018 and that data comes straight up. So now what I should be able to do is get a query going that says, hey, you know what? How much have I got? 2 minutes. All right, here we go. 2 minutes. We can do this. Go to the next slide, and I'll say, next slide, it's the real word. We're going to take the data from Redshift and do the same question, but go and get the information also aggregated up from S3 and join it together. And then what I want to see is, what are the top sales of tickets for what concerts? Fingers crossed. And there we go. So you can see that we've joined the two together. And you go, remember, that's a lot of data sitting in the back there, and it's got to try and work out, okay, of all the sales and all the joins that I've got, what are the top concerts that were out, and what were the ticket sales? It's fabricated, I won't lie. But it's effectively showing you the method that if you have things in Redshift super fast, you saw how quick that first query was when I did it in Redshift, just asking for sales locally. It's like a rocket. But then when you join it with S3, it says, well, okay, I'll go off to S3 via Glue. I'll go and get all of that aggregation and I'll work it all out, and then I'll bring it back through to Redshift, and then finally that leader node, that top level node says, I'm going to join that all together. And then because you've got this endpoint, this place where you can connect Tableau or Power BI or Click or QuickSight to, you can now grab that data. But none of that data, and you've got to remember, all of that data that's sitting in S3 is costing you 3 cents a gig. And if it's compressed, it's such a cheap option for you guys instead of holding all of this data inside Redshift. So I think that will do with that. I think we can go back to the presentation. I actually was meant to show you the next slide, which is really, that's the process. But that's what we've done. The only bit in the middle which is hidden, and you don't really see it when you're working with Redshift, is if you've got Glue sitting in the middle here, the connectivity between Redshift Spectrum and S3 up to Redshift is transparent. You don't even notice it. You're just doing SQL. All right. So why Modernize? Because you can actually take data today that's hot, have it all in a really fast location, allow that fast location to grow to meet the business requirements of today, to answer business questions right now that are really important, and you can grow that as needed. But finally, this cost component is such a driving factor for why people are choosing to go with Redshift and Redshift Spectrum. This ability to offload this massive set of data onto S3 and just bring it up as needed is such a powerful option. Okay, so thank you very much, everyone. Don't forget to do your tags at on the back to scan. Just give me a rating, make sure it's like 4 and above or something. I'm only the first one. You know how hard it is to be first? It's awful. But it's great to see you. It's great to have a great attendance and have a great Canberra Summit. There's some great presentations ahead for the day. Thank you very much.